Welcome to a refresher lesson for solving quadratic equations in our quadratic functions unit. This video corresponds to the examples on a worksheet packet that can be found at my Teachers Pay Teachers store. In this video, I will explain the skills and steps necessary to complete all of the examples on the worksheet. Please feel free to skip around to engage in the concepts with which you would like some help. When we are solving quadratic equations, you'll notice that there is only one variable now in our equations. If there were two variables, we wouldn't be able to solve. So we're just looking at one variable and we're trying to solve for x. Now, there are different methods for how you can do this. The first method we're going to look at is to take square roots. So this is a method you would use if you have an equation that looks like a vertex form, where you have a quantity squared, or if you only have an x squared term and no x term. So for this method, the first thing we want to do is we want to isolate this squared term. This is what we want to take the square root of. So anything else that is with that bit on the same side of the equation, we want to move over to the other side first using our order of operations. So I'm going to add 4 to both sides first. And then I will divide by that 2 on both sides. And I'll end up with a 2 equal to the quantity x minus 3 squared. Now I'm at a point where I can take the square root of both sides because I only have a squared quantity on one side of the equation. Now, one thing to keep in mind when you are working with square roots, when you are just asked to evaluate a square root. So if I ask you to evaluate what is the square root of 16, we usually only give the positive, or what's called the principal root, as an answer. So the square root of 16 is 4. Even though it is true that a negative 4 squared would also give you 16, in an evaluation kind of problem, we're only looking for positives. But when we are solving, we are looking for all possible solutions. And so when we are solving, if we take the square root of something, we need to give both the positive and the negative possibilities. So when I go back to my problem here, when I take the square root of both sides of this equation, I'm going to have a plus or minus square root of 2 on the left side equal to the x minus 3 on the right, because both the positive and the negative could possibly work as a solution. And now to get our x completely isolated to solve this equation, we will add the 3 to both sides. Now, general convention is that a non-square root number would come first, then the plus or minus, and then the square root. If you write it like this, it's not necessarily wrong, but you can see how it might get confusing here, because if your line gets a little bit too long, it's not going to be clear whether the 3 is supposed to be inside of the square root with the 2 or not. And so this is the better way to write your answer. Okay, try not to get things confused with that. All right, now, taking square roots is a method that works some of the time. It has limited use, I would say. More often, you are probably going to solve by factoring, if that's possible. So factoring is going to work usually if you have something that looks more like a standard form of the equation. In this case, we have the equation 4 equals 2x squared minus 9x minus 1. In order to use factoring as our method, the first thing we need to do is to get everything on one side of the equation equal to 0. So I need to move this 4 over to the other side of the equation. So I'll do that by subtracting. So I'll have the 0 on the left side, and then I'll have the 2x squared minus 9x, and then the negative 1 minus 4 would give me negative 5. And now I can look to see if factoring is an option. If you're not sure about factoring this with that 2 as a leading coefficient, you can go back to my properties and operations video to see how to do this. The way I do this is I look at a times c, which is going to be a negative 10. Then I look at all of the factor pairs of negative 10. So I've got a 2 and a negative 5. I've got a negative 2 and a positive 5. Then I've got a 1 and a negative 10. And I've got a negative 1 and a positive 10. And then I look at which of these are going to add up to my B value, which is a negative 9. So this is negative 3, this is positive 3, this is negative 9, this is positive 9. So this is the pair I want, and I'm going to use that pair to split my middle. So I keep the 0 equals 2x squared, and then I replace negative 9x with the positive 1 and the negative 10. I usually try to keep the positive in the middle of those two. And then I finish with that minus 5 that I had. Okay, and by splitting the middle, that creates 4 terms for me now, which I can now group. So I group the first 2 terms together and the last 2 terms together. And now from the first group, 2x squared minus 10x, I can factor out a 2x, which leaves me an x minus 5. From the second group, there really isn't anything that I can factor, so I'm just going to write a plus 1 out in front of it, and then keep that as x minus 5. And I know I'm on the right track because my 2 quantities now match, which is good. That's what I want. And so that quantity will get factored out, and the remaining terms will end up in the other quantity. Okay, so I've rewritten my standard form into factored form. At this point, since I know I want my answer to this product to be 0, I use what's called the zero product property, which says if I take A times B and I know it has to equal 0, then either the A had to equal 0 or the B had to equal 0 or both. And so that's what I do to finish this problem. I take each of these products. So basically this is my A, this is my B, and I set each one equal to 0. So either the x minus 5 factor had to equal 0, or the 2x plus 1 factor had to equal 0 in order to get this answer of 0. So in the first factor, I just add 5 to both sides, and one possible solution is that x equals 5. With my other factor, if I solve for x, I'm going to subtract 1 from both sides first, and then divide both sides by 2, and negative 1/2 would be the other possible solution. And that's normally what you're going to find with quadratics. You're normally going to get 2 solutions. Sometimes you get 1 solution. Sometimes you don't get any solutions, depending on the kind of results you get. But it should not be surprising that there are 2 possible values that would work in my equation. Now, when factoring does not work, and you have an equation that's in more of a standard form, another option is to use quadratic formula. Or even sometimes, for example, if you look at this equation and you think, oh, I don't really like that 2 as a leading coefficient to have to factor it. So even if it is possible to factor, you can still use quadratic formula if you feel more comfortable with that. Quadratic formula will always work on a standard form equation. Factoring obviously doesn't always work, but works a lot of the time. So again, we want to make sure that we have everything on one side equal to 0, which we do in this case, so we don't have to move anything over. And then we're going to identify what our A, B, and C values are. My A is 1, my B is a positive 6, my C is a negative 3. And then we're going to use the formula. The general formula says that X has to equal the opposite of B plus or minus the square root of B squared minus 4AC, and then all of that gets divided by 2 times A. Okay, so if we substitute our A, B, and C values into this formula, the opposite of B will be a negative 6. Then we have plus or minus the square root. The B squared is 6 squared minus 4, it's always 4, times the A, which is 1, times the C, which is negative 3. And then all of that will get divided by 2 times the A value, which again was 1. Okay, so now we start simplifying. So we have the negative 6 plus or minus. Inside of the square root sign, 6 squared is 36 minus 4 times 1 times negative 3 is a negative 12. And in the denominator, 2 times 1 is 2. So we've got negative 6 plus or minus the square root of, so this actually becomes 36 plus 12, which gives us a 48 divided by 2. Now, depending on what your teacher's expectations are, you could leave it like this, or if you're expected to simplify further, then you need to simplify your square root if possible, and in this case it is possible. And so remember, when you're simplifying square roots, you need to think about what are possible factor pairs for 48 that have one of the factors as a perfect square. So if I use 2, then the match to that pair is 24. Neither one of those is a perfect square, so that's not helpful. If I use 4, that's a perfect square. So that's one possibility. But if I think about a little bit more, I could also use 16, which would be times 3. And so I want to use the biggest possible perfect square factor to rewrite the square root of 48 as the square root of 16 times the square root of 3. And then the square root of 16 would become a 4. So 4 square root of 3 would be the simplified version of the square root of 48. So if I do that, if I continue down here, I now have negative 6 plus or minus a 4 root 3 divided by 2. And so now both of these numbers, which are not inside of a square root, so this one and this one, Both of those can actually be divided by this 2. And so we're going to do that. -3 plus or minus 2 square root of 3. We don't change anything inside the square root, okay, because that 2 is not inside of a square root. So we're only dealing with the numbers outside of the square root. And then because I divided everything by 2, that 2 technically becomes a 1. So my final answer is -3 plus or minus 2 square root of 3. And again, this really counts as 2 answers because I have a -3 plus 2 root 3, and I have a -3 minus 2 root 3 as the possibilities. So x could equal either one of those as a possible solution. Okay. Now, one final way that you can solve is by graphing, which maybe sounds a little bit strange, but it's actually a very helpful tool to be able to do. So if we are solving by graphing, again, with a standard form kind of equation, we first want to make sure that everything is equal to 0 on one side. So I'm going to subtract that 2 over and make this plus 8. Okay. And then in order to graph, I do need 2 variables instead of 1. And so we replace the y, we replace the 0 with a y. Okay, and that's what we graph. So you can go to a handheld graphing calculator. You can go to an app or a website like desmos.com and put in that equation to see what you get. I put mine into Desmos, and my graph looks like this. And so now what we're looking for is, where are the points for when y was equal to 0? Well, y equals 0 at x-intercepts. So that's what I'm going to look for. I'm going to look at the x-intercepts here and here and determine the x values at those x-intercepts. So here I have an x that's equal to 2, and here I have an x that is equal to 4. And so those will be my solutions. X equals 2 and x equals 4. Now, the reality is, a lot of times our solutions are not going to be nice whole numbers. So when that's the case, if I graph it, although I might see that I have some x-intercepts, it may not be easy to tell what those values are. So solving by graphing is probably not going to be a first choice. However, graphing can be a great way to check your algebraic work. So what I mean by that is, if I had this equation as one of the previous problems, and I take my 0 equals x squared minus 6x plus 8, and I do this algebraically. So maybe I decide to factor. This would be an x minus 4 and an x minus 2. And then I set each factor equal to 0, which means that this factor gives me x equals 4, and this factor gives me x equals 2. And then if I want to check that I've done that correctly, then I can go and graph it quick on a Desmos or my calculator and see that, yes, I did get an x-intercept at 2 and an x-intercept at 4. So it looks good. Even on problems like this one, where I get kind of strange answers, if I change those into decimals, I can still then tell on my graph whether those decimals look about right, whether the x-intercepts are in a place that correspond with those decimals. So graphing may not be your first choice in actually solving your equation, but it is a great way to check the solutions to your equation. I hope you have found this helpful. If you would like to see other concepts that you need to refresh or review, please check out my Gordon Global Math page on YouTube. Videos covering Algebra 2 and pre-calculus concepts will be added throughout the spring of 2025. Thanks for watching.